Testing. Testing. Do you hear me? Now, just like last time, I would like to invite you guys, right, for the coming chemistry lesson starting from today. Could you please open the camera? Let me know you are still here. Thank you. Now, this is the practice for next to be continued in the next week, as well as we have got a student there who will teach you in the following chapters. I know it is a very difficult times, cannot choose, but having a chance, right, for young men to have a practice. So next week I will still be here. Okay, I'm still in the Zoom lessons. So for the details, I will tell you next in the coming days. I don't know whether or not I will use my ID or his ID. Okay, I would like to talk to him as well. But as I that monthly service, so you know that not leave the classroom for the time being. So I would like to, I will ask for using my to continue using my ID, right, for the next for the lesson next week. Okay, any questions so far? Now, if not, last time we would have a rough on the topic alkaline, the reaction of alkaline. So let's have a look on this. Just wait and here. Okay, as I said before, could you please open the camera and let me know you're here. 21. One more guy missing. Oh, one more guy missing. 2. There should be 2, right? 23. Now, do you know we have got MC practice, right, in the Google Classroom? You know it? You know it? Or you don't know it? Okay, it's time to have a practice. Let me check the attendance first of all. Okay, let me check this. 25. Yes, that's right. All of you are here. Great. Xin Junke, are you here?
Yes, I'm here.
Yeah. Okay. Okay, do you find the book here? Now, so today we would like to continue on this. Now, take a look on our today's lesson. We will focus on the properties of alkaline. The reaction involved is a little bit difficult, I must tell. So that's why I asked you guys to read it through all those and take a look very carefully, such that you know what is that. So in short, what are the properties of alkaline? You may see it here. So very similar to acid, they are the good electrical conductor, and the reason behind is that it contains what? It contains what? Wang Xinhua?
Mobile ion.
Yeah, mobile ion. So all of you please mark it down. It's mobile ion. And it reacts with a solution containing certain metal ions to form precipitate is rather difficult. And I would like to have further explanation on this part today. And there is a reaction with ammonium compound to form ammonia. Okay, so this is what you may know. These two is our main focus. Okay, besides the alkaline, they would have to change its color with acid base indicator. For example, turn limit solution blue, beta orange yellow, phenolphthalein red. And if you touch it, this is slippery. While if you taste it, okay, if you accidentally do so, right, you may feel a little bit bitter. So this is what you may know this part. Okay, so highlight this part. So and as I said before, conductivity is because of mobile ions. Okay, for carrying the current, and depending on the strength of the alkali, the brightness of the light bulb is different. Okay, depend on what? Depend on the concentration. Or if you please mark it down. So depends on the concentration of mobile ion. The more concentrated the mobile ion, the brighter the light bulb will be. So of course, the concentration of mobile ion will be depending on what? Will be depending on what? Do you know? Chen Yu, could you please give me one factors? What can we do? Well, if you have got an alkali, to make the light bulb brighter, right? This is what you can control. The choice of the alkali.
Maybe use a more concentrated.
Good. Concentrated. More concentrated alkaline. Yes, that's right. So the concentration of alkali can affect the concentration of mobile ion. As said before, the more concentrated the alkaline, the more the concentrated mobile ions it is. Yes, that's right. How about the another factor? Oh,
Number of mobile ion.
Number of mobile ion. How will you control the number of mobile ion? Can you control? Now, something that you can control, for example, concentration of alkaline. This is what you can control. Okay. How about the nature of alkaline? So the nature of alkaline, you cannot control. So the another factor you may write down is on the strength of alkaline, 強度. So this is what you cannot control. It depends on the chemical nature of the alkaline. For example, if you have got 1 molar of NaOH and 1 molar ammonia solution to compare, the concentration of mobile ion for this one, NaOH, it is more concentrated, so it will make the light bulb brighter. The reason behind is that it contains more mobile ion. How about this? Why is it having lower concentration of mobile ion? 真的, do you know?
Is related to their bonding.
It related to what?
Their bonding.
Bonding. Could you please elaborate more? Now it doesn't matter. Yeah. Mm-hmm. Yeah.
There is an hydroxide ion.
Mm-hmm. Mm-hmm.
And I'm not sure.
Yeah, it doesn't matter. I would get what you mean about the bonding. This one, it is in the ionic bond. Okay, it's an ionic compound. So you may know once I dissolve in water, it fully dissociate. It fully dissociate. Can you see that? Dissociate. So we have got a 100% dissociation to form sodium ion and hydroxide ion. So in other words, if you want to talk about concentration of mobile ion for 1 molar NaOH, it is about 2 molar of mobile ion. Do you know why? You split NaOH into half, we may have Na plus OH minus. So for 1 molar NaOH concentration, it will contain 2 molar of mobile ion. However, when you have got 1 molar NH3, they will have a much smaller than 2 molar mobile ion. Even 1 molar, it will be smaller than 1 molar. Why? Because of this. We call ammonia a weak alkaline. It's because indeed, first of all, both ammonia and water, they are just molecules. It cannot conduct electricity. However, why we say that it contains mobile ion is because it ionizes in water. But the degree of ionization is not 100%. So that's why you may see this arrow, that double arrow here, right? To tell the reaction being reversible. In other words, you may describe that ammonia is a weak alkaline. As I said before, ionization is just slight, partial, incomplete. Okay, can you get my point? You may use the word slight, you may use the word partial. Okay, not complete, incomplete ionization. Is that clear? Any questions so far? Now, do you mean that, Mr. Chin, would they have a very similar comparison when you talk about acid? Yes, correct. Okay, go back to acid. Now, if you talk about acid, of course, acid can also conduct electricity. So because of the presence of mobile ion. Now, acid molecules itself, they cannot conduct electricity. But in water, it can. It's because of ionization. So if you use a stronger acid, right? When you're having the 2 acid of the same concentration as a comparison, the stronger acid will have got a higher concentration of mobile ion, which leads to the light bulb brighter. Can you get my point? So for the acid, if I adjust it to be more concentrated, the light bulb will be brighter. There is one more factor for acid. What is that? In which you will not find it in alkaline. What is that one more factor found in this? if I change the whole thing to alkaline, there's one more factor not mentioned. Anyone who can try? Anyone who know? Sĩ Đồ Hoàng Niên. There's one more factor. Now, to take a look on the axis, we will usually talk about what? How about 1 molar of, I give you one hint. How about 1 molar of HCl and 1 molar of H2SO4? And I test its electrical conductivity. Which one would have a higher electrical conductivity?
HCl.
HCl, why?
Reactivity.
Reactivity of HCl is higher than sulfuric acid, you mean? Now I repeat here, for this one, the brightness of a light bulb, again, I draw the same thing, okay? The brightness of light bulb, it will be affected by what? It would it is just an indirect measure of the concentration of mobile ion. Can you see that? So the concentration of mobile ion will be much depending on the 3 factors. Number 1, concentration of acid. The more the concentration, the acid, for example, 1 molar HCl versus 2 molar of HCl. Of course, this one it is of higher concentration. You all got it? Right? Second, strength of acid. For example, 1 molar HCl versus 1 molar CH3COOH. Do you still remember that acid? Which one will cause the light bulb brighter? You know? HCl and ethane acid, which one will make the light bulb brighter? Ethanoic acid. Agree? How about the others? All agree? All agree? No idea. Now, indeed, if you check the strength of acid, you talk about what degree of ionization. Now, I'll give you some time to check on the web now, degree of ionization of acid. Which one is a stronger acid? If you said there's a stronger acid, which means that you have a more complete ionization. If the ionization is more complete, the mobile ions concentration will become higher. So that the one this is the answer. Please search for me. Which one is a stronger acid? And you may turn on the mic and tell me, or you type it in the chat box. Let me know. Which one? Which one is a strong acid? Now it depends on the degree. Yes, that's right. HCl is a strong acid. So this one is a 100% ionization. While for this one, it's a very slight ionization. It's just 5 to 6% ionization. But for this is about 100%. That's right. So how about the strong acid? It will contribute to the high concentration of both ion. How about the last one? I give you one example: HCl, H2SO4. So what factors are we comparing? Do you know what factors are we comparing? 1 mole HCl, 1 mole H2SO4.
Number of number of hydrogens in
Number of hydrogen ions in the molecule. Can we have ions in a molecule? Can you change the wording a little bit? Under what situation will the acid molecules will form ion? A process that will be formed. Except before I just read out that word. This word.
ionization.
Yeah, ionization. So if you want to talk about the maximum number of hydrogen atoms found inside the acid molecule that can be ionized. So what factors are we talking about? We call that basicity. Basicity 鹽基度. So you want to talk compare the two. This one will cause the light bulb brighter. It's because of the higher concentration of both ion. Why? Because they will have more concentrated hydrogen ion. Can you see that? All of you, could you please mark it here? So for the acid and alkaline, the brightness of light bulb, the factors affecting the brightness of light bulb is different. Well, for the second factor, the third factor, the middle one and the right one, they are more or less the same as alkali. But for alkali, we do not have any concept of basicity. Right? For acid, we have. So I try to add it here as well to let you know. It's something strong. Okay, so you may know it in the next chapter as well. And we have a recap of this. Any questions so far? Any questions? Okay. All of you have copied? Maybe you capture the screen first, okay? All right. Shall we move on? Okay. Now, so if you want to talk about electrical conductivity, if you want to go to have a deeper explanation, it is the one. Now, today we go something more about chemistry this time. What happened? Oh yeah. Why is that page missing? So strange. I need to cover all. Oh no. Do it again. Yes, that's right. So what's next is to talk about the reaction of dilute NaOH solution with that contain metal ions. A very important concept, and I will urge you guys to memorize it. Okay, you have to memorize it in preparation of a big assessment. Most metal hydroxide is said that it is insoluble, right? As I said before, you want to talk about the slight difference between the base and the alkali. So you know that some except group 1 hydroxide, which are water soluble. Most are metal soluble, they are insoluble. So if I add a few drops, take a look on that very carefully, a few drops of NaOH, okay? So most of the solution you may check that calcium, magnesium, aluminium, lead-2, zinc, iron, copper. Oh, very similar, right? Very similar to what we will see. Metal relativity series, right? Very similar. Those commonly found ions, so we find that sodium ion, potassium ion, no PBT. Because as I said before, all group 1 compounds, they are water soluble. Okay, so just count potassium, sodium, calcium, magnesium, aluminium, zinc, iron. We've got the 2, right? Lead, copper. Do you see it, right? Very similar to what you know about the metal relativity series. Okay, so how about mercury, sulfur, gold? Very rare, because they are very stable. So it is quite difficult to find its own ions here. How about mercury? Mercury, do you have mercury ion? The answer is yes, but we seldom talk about this because it's rather toxic. So we seldom use this in our lab. So you just skip it. But for silver ion, silver nitrate solution, you usually use it. So I try to add it here as well. So what is the use of this? Now, I would like to recall your memory about the video that I showed you, right, last week. What does it tell? If I add the alkaline to it, it will form some PBT. Now, if you want to go to the study deeper, you may have quite a different description. I'm sorry, description on the color of the PBT. Can you see that? You have to memorize any pattern. 又係啦，我要記咁多，咁我點記到咁多咧？嗱 ，any pattern 點樣方便自己記到啊？
淨係 iron 同埋 copper 會有 color。
Iron and copper they have color. How about the others? They are just what is the color of the other? What is the color of the other PBT? They are just white. Can you see that? They are just white. And second, yes, that's right. So it is much related to what? Why? 點解嘅？點解會淨係得嗰幾個有顏色嘅？
淨係 transition metal 先有色。
Yes, only transition metal ions will have color. Remember, transition metal ions will have color. Transition metal itself, it will have mainly silvery or some golden, reddish brown as well. Okay, color. So this is how we try to memorize. And what's next is on that 3, iron 2 hydroxide. Iron 3 hydroxide, copper 2 hydroxide. The color of it is a little bit different from the solution, isn't it? From the solution, you want to describe iron 2, you use the word pale green. How about this? It's no longer pale green. It seems darker. It seems more nasty. So that's why we would describe the term dirty. Dirty green. All of you, please mark it down. It is a dirty green PBT. Okay, it tells you the presence of iron 2. How about this? We will call that the color of it very rusty, isn't it, right? So indeed, the color of it seems like rust. We will describe rust as a reddish brown solid. You borrow the same adjective, you put it here. Finally, for copper 2 iron. Copper 2 iron. So what is the color? We call it pale blue. 粉藍色係嘛 ？We call it pale blue. PPT. PALE BLUE. Pale blue PPT. All of you, please mark it down. So this is what I would like to talk to you here, right? So change a little bit here. So it is dirty green. Reddish brown, pale blue. Okay, what else? Have you checked for the texture of those PVD? The texture of those is a little bit different. So if you want to talk about this, besides this is white, we will use the word jelly-like or powdery to further describe. For example, for calcium hydroxide, it is said to be a powdery precipitate. Powdery. But for Mg2+, we will call that a jelly-like or use the word gelatinous. Gelatinous precipitate. The texture is a little bit different. Okay. So similarly for aluminium, okay. But for iron lead-2, it is powdery. Zinc, jelly-like. And iron-2, iron-3, they are also jelly-like. But it doesn't matter, even though you do not see it as jelly-like, based on the color, you can easily distinguish which is which. How about copper 2? It's also jelly-like. So the reason behind is that we have got the precipitate of hydroxide. Can you see that? Okay. So if you want to talk about the chemical reaction, we focus on Ionic equation. Take a look. Ionic equation. This is the Ionic equation. It is simply adding the magnesium ion or some other ion with hydroxide to form that hydroxide with write it down as solid. This is very special. So similarly, if I change it to lead-2, can you see that? Lead-2 ion, aluminium ion, zinc ion. If I add it with hydroxide to form its hydroxide, PPT, the reaction is more or less similar. Okay, is that clear? It's Ionic equation. How about this? What will happen? It's quite difficult. Mr. Chin, I still find it difficult to distinguish between these 5. Calcium, magnesium, aluminium, lead-2, and zinc. Why? Because all of them, they are said to be white PPT. Right? But somebody may think that like this way, okay? Mr. G, if I take a look in whether it's powdery or jelly-like, I can further split into 2 groups. Yes, that's right. But you still cannot find, for example, calcium and lead. Okay, you see that? Calcium, iron, and lead-2 ion, right? It is also both they are powdery. How would you further distinguish which is which? Now, there are so many methods. For example, to use flame test, right? Calcium ion, they will exhibit green, brick red flame. Okay, but not for lead. This is one way. But if you use alkaline, you can further help. It's done by what? It's done by adding excess circle the word excess NaOH, and it will give you further different observation. Now take a look on why. Now you may see calcium hydroxide, magnesium iron, the PBT will not be dissolved. But for aluminium, lead, and zinc hydroxide, once it's formed as hydroxide, the PBT will dissolve it to give a colorless solution. How about the other colored chemicals? Iron 2 hydroxide, iron 3 hydroxide, copper 2 hydroxide, the PBT does not dissolve. So the difference is because of that word complex, 落合物. So it is it's a very special chemical. Now, for example, if you want to talk about aluminium, lead 2, and zinc hydroxide, the chemical to be formed will be this. Okay, all of you, please mark it down. This 3 equation is very special. It tells you when I add alkaline in excess. So that is the reaction. So what is meant by complex? Complex is a very special chemical, okay, in which the structure is a little bit complicated. For example, Al bracket OH and then minus. So you will have this. The formula, the structure of this is of this. Can you see that? What is that arrow? Just remember the arrow? You may have heard it before in bonding. What is that bond? Gentlemen, do you still remember? What is that bond?
Dative covalent bond.
Yeah, dative covalent bond. Indeed, it is quite common to see the transistor metal ions itself as a central ion, while it will be surrounded by some other chemical. It can be ions, it can be small ion, or it can be small molecules having lone pair electrons. They will itself they have a connection. We call it dative covalent bond. Now, similarly, for lead 2, it will be this. For zinc iron, the complex to be formed is also this. Very similar, right? So how will you call this? Now we have got so many different naming systems for a complex. For aluminium, the complex we call that tetrahydroxyl aluminate ion. What is that? What is mean by that? Tetrahydroxyl aluminate. What is that? So tetra means 4, hydroxyl means hydroxide, aluminate, which means that it is an anion. Okay, but we have got aluminium as a central ion. Is that clear? So it's not that strange to you. For example, if you recall your memory in September, you memorize the term MnO4 minus, a permanganate, dichromate. Okay, so you may see the word ATE again. Recall your memory. Whenever you see the word ATE, which means the ion having a negative charge. Now, somebody, if you search on the web, you may see you got another name for this complex. We will call that aluminate. Plumbate. And also zincate. It is also possible to write like this. Okay, I would like to draw attention to the word plumbate. Why would we say that plumbate but not lactate? Now you need to follow the rules, sticking back to the Latin name of the chemical, in which you may find it into your symbol. Now, similarly, do you still remember that? Do you still remember that? In rusting, it's a rust indicator. How will you call it? Hexacyanoferrate 3. So why you say that a ferrate? It gives the same reason, but not ironate, right? We call it ferrate. So this is what I would like to draw attention. All of you should memorize this by heart. Any questions? Now, for those who understand what I've just said, could you please put a tick? If not, put a cross. How about, yes, I'm waiting for the others. Mr. Chin, how about silver iron? Now, silver iron is a very special case. For silver iron, the PPT will be formed is brown. Or use the word gray, PPT. But for the chemical, we do not have any silver hydroxide. Instead, we have got silver 1 oxide. We have got silver 1 oxide. So I would like to ask you guys how to write down the equation. Now you may search on the web now. What is the chemical reaction involved? Mahin, please search. Now, for those who have searched it, well, as well, you may type it in the chat box, or you may turn on the mic and tell. What is the reaction? Oh, him, what do you search? My question is having silver ion react with hydroxide to form silver oxide. You search it again. I said before, no silver hydroxide in reality. Can you find it? Have you found it? So this is what I would like to draw attention. Now, this part is very special case. The PPT, the color of the PPT as well as the equation. Is that clear? Now, why did Mr. Chin tell it so slowly? Because once you understand the concept of NaOH, I would speed it up if I have it as ammonia. Now, indeed, for ammonia, it is the chemistry is very similar. As said before, if I have the solution containing sodium ion, potassium ion, if I add ammonia to it, sorry, no PPT. When I add it to it, because there's no other combinations of having group 1 compound being water insoluble. In other words, all metal 1 for group 1 metal compounds, they are water soluble. Now, leaving behind is on this. Is it very similar? Take a look on this and check it against page 18. Are they nearly the same? One is missing. What is that? One is missing. Can you find it? One is missing. Then you compare with page 18.
Calcium.
Which metal ion? Yeah, calcium. Calcium ion, they are missing. So indeed, calcium, once I react with ammonia to it, they will not form any calcium hydroxide. Now that is the reason. Can you see that? Because for ammonia, the concentration of hydroxide ion is rather low. Why? Because as I said before, ammonia is said to be a weak alkaline, so you will have a slight ionization in water to produce less concentrated hydroxide ion. So the hydroxide, once they are still there, they will just combine with calcium. But as said before, calcium hydroxide, we call it lime water, right? Is still a slightly soluble chemical. So so the hydroxide ion is not in large amounts such to produce PPT. So we will have no precipitate. All of you, please mark it down. Calcium, no PPT. Okay. So what is the hidden message? Indeed, if you want to talk about the addition of a few drops of ammonia solution into some other metal ions, the PPT is also formed is because of the reaction between metal ions and hydroxide. How will you get the hydroxide? The hydroxide comes from the ionization of ammonia in water. All of you, please mark it down. So if you write down the equation, that is the very first equation. While you have got this, it will react with a magnesium ion, they will form magnesium hydroxide. Can you get my point? So you use the same tricks and you would know the others I will not mention. It's too easy to understand. But the more complicated way is to take a look at the word. How about in excess ammonia? So the observation, please compare this one with page 18. What is the difference? What is the difference? Can you highlight for me which one is different? Which observation, when you talk about excess alkaline added, is different when you talk about NaOH and ammonia? In terms of observation.
The copper to iron the PBT will dissolve and give a deep blue solution.
Yeah. How about NaOH? If I add excess NaOH, the PBT still remains. Okay. How about the others? Anyone who can try? 仲有啲 observations 係唔一樣嘅。趙千瑞 could you search？ 做邊幾個係唔一樣啊？
呢個鋅係 dissolve，precision dissolve，佢呢個 color solution。
Yes. One more. Two more. 仲有兩個係唔一樣嘅。揾到。How about for zinc? If I add excess hydroxide, the PBT will dissolve to form a complex. We call it zincate. Okay. How about ammonia? The PBT will dissolve it to give a colorless solution, but it's not zincate. Now, even though the observation is the same, the equation is different. It's a very special case. How about the other two? We have got aluminium hydroxide and black 2 hydroxide. While you see that the PBT does not dissolve. Okay, can you see that? So I would like to draw attention to that 1, 2, 3, 4 equations. Okay, it is quite different. So I would like to draw attention to the complex formation. 1, for copper. For copper, once I add ammonia to it, while I add just a little bit of ammonia, the PBT here is just pale blue. But if I put it into the excess alkali, especially ammonia, the PBT will dissolve to form a deep blue solution. But that deep blue solution, the color of it seems much like a blue ink, right, in the ball pen, right? With that color, very similar. That complex is very special. We will call that tetramine copper to iron. Tetra means 4, amine means ammonia surrounding to the complex to form a copper 2 iron, not cuprate this time, right? Why? Because it is a cation. So you still stick back to the name copper iron, but not cuprate iron. So the complex form is of this. Now please take note that for each ammonia is of no charge. Okay, while for copper 2 iron, we have got 2+ charge. The overall charge is 2+, but not zincate, but not aluminium. Why? Because for the aluminium, zinc, you see that the charge, why is it say negative? It's by the addition and subtraction. Aluminium ion is 3+. 1 hydroxide is 1 minus, right? We've got 4, 3 minus 4 equals minus. 使唔使計啊？呢個 charge So you may find this one being 3 plus and this minus, 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 altogether is minus. But for this, it is 2 plus, but this one 0, 0, 0, 0, altogether is 2 plus. Now, this is a very special equation I would like to draw attention. Besides, we've got one more, zinc ion. The zinc ion, they will redissolve into excess ammonia to form tetramine zinc, tetramine zinc ion. Now, remember, zinc ion, when we need to write down zinc 2 ion, is because zinc ion, they have just one oxidation number. There's just one oxidation stage. This is +2. So you need not intentionally write it as 2, state is 2, and let me know it's 2. But not for iron 2, iron 3, right? Because they have quite different oxidation state. You want to tell which is which, so you will write down as +2 and +3, show it as 2 and 3 respectively. Any questions? That means, Mr. Shin, you mean that you need to memorize that 2 equation? Yes, that's right. Now, but for that 2 equation difference between them with any which is that if I put it in excess, that is ammonia which play a role, which will make the complex form. Okay, while for excess NaOH, the reaction, you will say that you want to talk about complex, is say thanks to the presence of hydroxide ion. Is that clear? Okay, one more missing. Mr. Shin, how about sulfur ion? How about in alkali? How about in alkaline? There are 2 types of alkaline. Now the difference is that if I put it in excess NaOH, that sulfur oxide PPT does not dissolve. But if I put it into excess sulfur, ammonia into sulfur ion, the ones first of all, for little ammonia added, they will have gray PPT or brown PPT. And if I add excess ammonia, the PPT will dissolve. To forgive a colorless solution. So what is the equation? All of you please mark it down. Now, very, very special. For sulfur ion, it will react with hydroxide to form sulfur 1 oxide. While the sulfur oxide, they will form a complex. We'll call that tetramine. It's not tetramine, it's diamine. Diamine sulfur ion or diamine sulfur 1 ion. Now, could you please help try to balance the equation? Okay, while the diamond silver 1 ion is in form of a colorless solution, the colorless precipitate. So you need to have a combination of both reactions for you to help recognize which is which. Especially for those white precipitates, it will be quite hard to understand. You will quite hard to find. This is what you need to know. Any questions so far? Have you all covered it down? Now, last but not least, you have got one more equations. The third type of equation, this is our common today's core topic, is an ammonium compound. When I react with hydroxide, they would under heating, they will form ammonia as a product. So this is what I would like to get approach to the problem. Nitrate here, okay, and sodium ion to form what? Sodium nitrate. So leaving behind is on that ammonium ion, hydroxide ion to form ammonia and water. So that's why when once I write down the ionic equation, it will be written like this. Can you see that? The green one goes together with green one. Okay, now this is what you get approach to the problem. So if you want to get the production of ammonia gas, now it is the only alkaline gas, in DSE. So you are going to test it by what? Moist, red, litmus paper. While the observation, the red paper turns blue. So this is the proper test to test for the presence of ammonia. Of course, smelling will give you a hint. If you smell it, it will give you a pungent smell. 攻鼻嘅刺鼻嘅。It's a pungent gas. Pungent. 刺鼻嘅 P-U-N-G-E-N-T. Any questions? Now that's the end of the lecture today. I would like to have you draw attention to do the class practice 14.5. Try to do it now. This is on page 24. Let's have a try. The anyway solution would be added to some the four chemicals. Give the four chemical formula of the green PPT formed from the reaction between iron 2 sulfate and the dilute NaOH solution, or this one. That green PPT, as said before, I describe it as dirty green. What is the chemical formula for this A part? What is that? What is that?
There's a
Chemical formula.
a FeOH2.
Yes, it's iron 2 hydroxide, FeOH2, bracket 2. How about B? What would be observed when dilute NaOH solution was added to iron 3 chloride here? So what is the observation? Yong Seng-hin, what is the observation? What is the observation?
In reddish brown precipitate forms.
Yep, reddish brown precipitate. Now remember, in your quiz or in exam, you have to write down the full term. So the equation is very simple. You write down the Ionic equation, right? Ionic equation is very simple. Now remember this one solid to tell it's the precipitate, okay? How about C? Name the one precipitate formed in a reaction between aluminium sulfate and sodium hydroxide solution. What precipitates? C, here. That white PPT, what is that? 中號證。What is the PPT?
Aluminium hydroxide.
Yep, aluminium hydroxide. So if you write down the name, the white PPT, right? So it's aluminium hydroxide. So indeed, the formula is AlOH3. The white PPT dissolved in excess NaOH to give a colorless solution. Explain with the aid of the equation. So what is the equation? What is happening? Aluminium hydroxide, they will dissolve in excess NaOH to form a colorless water soluble complex salt. Okay, so what is the complex salt? Aluminate iron. So the equation is AlOH3 solid plus hydroxide to form AlOH4 minus AQ. Now remember to check the physical state. Why we say that complex salt, water soluble, okay? So you mark it AQ. How about D? Name gas A. Oh, what happened? If I add NaOH hydroxide react with ammonium ion to form a gas. What is that gas? And write down the Ionic equation. Makinya. What is the gas? The equation? What is the product? If I write down ammonia, besides ammonia, what happens? What will be formed?
HCI.
Oh, so this is water, okay, ammonia and H2O. So we just stop it here. Thank you for coming. And question 2, you do it at homework and you we will continue in the next lesson. Before you leave, let me know your understanding. And then tell me any difficult part before you leave. Okay? Now, this is the one. Now you may capture the screen and you are going to get prepared for the next lesson. See you. Okay, bye-bye.
Bye bye.